In this quick video, we're going to look at the renal system or urinary system. So here we see the model of a kidney. This is a three-dimensional model. It's been sectioned to expose the internal anatomy. The pink tissue you see on this outer perimeter is called renal cortex. Renal cortex. Internal to that, right here, is your renal medulla. Now the renal medulla is made up of these structures called renal pyramids or medullary pyramids. Each pyramid will terminate at this structure called a renal papilla, and they'll empty into these minor calyxes. So each renal pyramid will empty into a minor calyx you see here and here. The minor calyxes will dump into these major calyxes, and all of the major calyxes will then empty their product into the renal pelvis. What we're speaking of is urine. The renal pelvis will convey the urine into the ureter, and the ureter to the urinary bladder until a person urinates, or micturates as the clinical term would be. Here we can see the renal artery. Now this would be coming directly off the abdominal aorta, and it would branch into segmental arteries. It would go on to branch into interlobar arteries, and at that point it would form arcuate arteries. If you look right here, you can see this arcuate artery as it forms an arc and a boundary between the renal cortex and the renal medulla. The same is true of the arcuate vein that you can see represented here. Now we'll go into another model that was going to show us a little bit more detail, and we'll be able to look at a nephron. The nephron is the actual functional unit of the kidney. So let's move into the other series of models and take a look at that right now. So here's that same model of the kidney, only instead of being mounted on a stand, it's on a board, and you can see other components showing bigger representations of the internal structure. On the left here, you see the same kidney we saw, the same idea of it, the renal pyramids making up the renal medulla, and of course the cortical tissue around that. Your renal artery coming into your segmental artery, and on. You can see the renal papilla of each renal pyramid emptying into a minor calyx, into the major calyx, into the renal pelvis, and into the ureter, as described earlier. But you see something else here. So let me zoom in on this, and what you'll notice are representations of the nephrons here. Now the nephrons are the functional units of the kidney. You have more than 1 million per kidney, so plenty of renal tissue to filter the blood. Here are your nephrons. Now, these show very little detail other than you can see there are renal tubules, a collecting duct, and these little Bowman's capsules. But if we move to the next segment of this model, which is one renal lobe, and a renal lobe consists of one pyramid and its associated cortical tissue. You can also see the nephrons here dumping into the collecting duct, and where you see each one of these little extensions would represent another nephron dumping into the same collecting duct, and multiple collecting ducts will empty into the papilla, and so on. So a renal nephron consists of the glomerulus, which is this extension of capillaries inside this Bowman's capsule, this little aggregate of capillaries. It also has a proximal convoluted tubule, which is physically connected to the Bowman's capsule, the loop of Henle, and then a distal convoluted tubule, which dumps directly into the collecting duct. You can see another one here on the other side doing the same thing. This is that arcuate artery and vein that we saw in the initial segment, separating or delineating between cortex and medulla, and it also gives this branch of the interlobular artery, which then goes on to branch off into the afferent arteriole. That's the little arteriole that first feeds the glomerulus. This is, again, still a little more detail, but not big enough to see what we want to see. So let's move over to this portion of the model. And here we see an enlargement of a glomerulus. So the glomerulus, again, the aggregate of capillaries inside, has an afferent arteriole coming in and an efferent arteriole leaving. You notice the afferent arteriole is in greater diameter than the efferent, so more blood is able to enter the glomerulus than is able to leave in that same unit of time, and so you get pressure in here, and that's the first part of urine formation, is called glomerular filtration. It's pressure filtration, and that's why in this representation they've changed the different colors here. This denotes that product is being filtered out of the glomerulus into this capsular space between the glomerulus and the Bowman's capsule. And then what doesn't get filtered out remains in this glomerulus on the other end and exits through the efferent arteriole. What does get filtered out will then become filtrate and enter into this proximal convoluted tubule, where most of it will be recaptured, but the idea is to pull out the things we don't need, regain the things that we do need, and what we leave in the renal tubules and into the collecting duct ultimately becomes urine. This is your distal convoluted tubule. Now there's some cells here called macula densa cells that, along with these cells, which are the juxtaglomerular apparatus, will monitor the blood and release things like erythropoietin to increase red blood cell production if necessary. So these are the basic components of your kidney, all represented on one model in greater detail so we can see what the actual nephrons with the glomeruli look like. So just to conclude this video, I wanted to use this simple model, which is an overview of the entire renal system. So for orientation, this is the right kidney and the left kidney. This is an anterior view. You can see the adrenal glands on top of each kidney, sometimes referred to as suprarenal glands. This is your abdominal aorta and your inferior vena cava. So coming off the abdominal aorta, we have a renal artery going to the left and right kidneys. And those will branch off and go down to the level of the glomerulus that we described earlier, where pressure filtration begins, which is the first part of urine formation. And then the venous return of that blood will be through these renal veins, one from each kidney, entering into the inferior vena cava to lead back to the heart. In this right kidney, they've bivalved it, so you can see the cortical tissue and the renal pyramids where our nephrons reside. They will produce the product of urine and dump into the minor calyx system, and from there into the major calyx system, into the renal pelvis, and then down the ureters. So you can see a ureter coming from each kidney, and that will be conveyed down to the urinary bladder, where we store urine until we have the urge to urinate. Again, this is an anterior view, so you're looking at the pubic bones here and your pubic symphysis. But if I were to turn this around, as we come down here now, you'll see this is representing a male model, male urinary system, because this is your urinary bladder, but here we see the vas deferens, the seminal vesicles, and then this prostate gland right here. That's representative of a male. And if you've watched the video on the reproduction models, you'll recognize those from the male reproductive system. So that's it. That's just a quick overview of the entire renal system to conclude this video.